So another thing that the attentional learning system is doing is learning. Our neural networks learn layer by layer usually, and it's relatively slow and inefficient because we need to change so many links. So imagine you want to teach a neural system to play tennis, and you do this end-to-end learning. Every time you do the beating in the wrong way, you will have to change all the links. Even the perceptual system has to be adapted and so on. It's only that you, by accumulating lots and lots of training data, all these changes cancel each other out, except for the change that you need to make to get better at playing tennis. And you can improve on this very slow algorithm by pinpointing the position, like improving my upper hand or something like this, with attention. And this is what your conductor is doing. So when you want to get better at tennis, you say, okay, when this ball comes like this, I will move my hand slightly different than I normally do, and I will make this. And I hope that this following thing will emerge. And this is what you store on your protocol memory. Yes. And a few moments later, when you see how this worked out, you'll recall the original situation and you can reinforce or undo the change. And this is a very efficient learning algorithm that our brain is using and our machines are only beginning to approximate. So another part is what happens if, like in tennis, it takes a while until you see the result. It might take a few seconds or it might take minutes until the match is over. And many things that we change, we only see how the crops turn out next year. So that's why you need to have this long-term memory and this long-term stored consciousness, this with wide span of its stream of attention. But when you see the changes immediately, this is when you do things on your mental stage, you reason. So reason is in some sense learning that with immediate results. You try something and you immediately see in your mind, in your mental simulation of how it turns out.
Yes.
And then you fix it. And then you go on to the next step. And this step-by-step improvement of a mental representation is the same thing, I think, as attentional learning. It's enabled by the same mechanisms. So this conductor is, therefore, reasoning is conscious because it's done by this mechanism that uses protocol memory and this conductor system to see, to affect a change and see how it turns out and sees whether it needs to be reinforced or undone.
Yes, yes.
So in some sense, these different modules are done by an orchestra. Our brain areas, something like 50 or so brain areas, could be seen as something like 50 instruments that talk to each other. They basically listen to the music of their neighbors, to the surface of the music they are doing. And you have a conductor that directs your attention between them. And the conductor is controlling what you are playing tonight. At least that's my hypothesis. So I think it's actually a combination of stuff that happens in the dorsolateral prefrontal cortex and the insula and the thalamic loop. And hippocampus plays an important role in storing the scripts that you, and basically maintaining the scene graph of the situation that you're in and your plans. But the actual attention seems to be directed from there, as far as I understand. So the individual contribution is not that important. The important thing is really it all needs to make sense in the big pattern. There is only a particular universe that can contain you. There are not many possible universes in which you can be contained. And this constrains what music the individual orchestra members can play. And the smaller they are, the more expendable they are, and the more they have to adapt to the structures around them.